The next module I'm going to discuss is flow in pipes and hoses. Now, how do you determine how much water is flowing in a pipe or hose? Well, this is the formula here. Q equals VA, where Q is the quantity of water in meters cubed a second, V is the velocity in meters a second, and A is the area in meters squared. So how much water is flowing in a pipe when the area of the pipe is 0.5 square metres and it's travelling at 5 metres a second? Well, if you put in your known variables, you get Q equals 5 times 0.5, which equates to 2.5 metres cubed a second. Now, I want to ensure that you understand that this flow will remain constant, and this can be explained by saying this. V1A1 equals V2A2. The velocity of water times the area at point 1 in the system will be the same as the velocity at point 2 times the area at point 2. That's the key. You've got to remember that the quantity of water is the same. If you increase the velocity, it will reduce the area. If you reduce the area, it will increase the velocity. Another formula we want to try and remember is this one here. And this is a fire service formula. L equals VD squared divided by 21.2, where L is the flow in litres per minute, V is the velocity in metres a second, and the D is the diameter in millimetres. Now, this formula is commonly applied to determine flow in hoses and is used, like I said, in the fire service. Let's do an example. Determine the flow in a 45mm hose when the water is flowing at 6 metres a second. Well, if you put the known variables in, as you can see here, when you multiply that out, it gives you a flow of 573 litres per minute. Let's do another example. Determine the flow in a 70mm hose when the water is flowing at 4.5 metres a second. Well, if you put the known variables in the formula here, it gives you a flow of 1040 litres a minute.